Hello, I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today I'm speaking with Clint Quanstrom with Parker Hannifin to discuss the use of IoT in fluid power applications. So thank you, Clint, for speaking with me today.
Yeah, for having me, Sarah. I appreciate it.
So maybe if you could just kind of start going into some of the ways that Parker Hannifin has been integrating the Internet of Things into fluid power systems in off-highway applications, or sort of maybe trends it's seeing in the use of IoT for these systems.
Sure. Starting at the highest level and sort of the foundation for all this, telematics has been around for a while, right? It's been around for over a decade. There are a lot of companies that can connect an off-highway machine and provide location, provide diagnostic messages off of the engine control unit or the transmission. And Parker has that capability as well. That's kind of the starting point for us. How we make it more mobile IoT and less telematics is by integrating with the motion systems that are on board these mobile machines. And they could be hydraulic, they could be pneumatic. There's a lot more electronics going on that we see today versus driving off of traditional diesel power. And we provide equipment in all those motion systems. So the way we move beyond telematics is in a couple of areas. And first and foremost is connecting with the controllers that are on those machines. So for those motion systems, there's going to be a mobile controller there, and that is driving all of the activities of the hydraulics or the pneumatics. So making the boom go up and down or extending it in and out. There's a controller involved, and there's programs running on that. When we connect with that controller in a meaningful way, it enables over-the-air operations for our customers and their customers' customers. And that's going to allow them to remotely dial into those machines and do many things. They could change the program if they want. They can look at high-speed data on the bus in real time and diagnose problems that they see with the machine. And that's going to allow them to be much more efficient in their servicing of the machine, because you don't have to dispatch somebody to the field to find out what's wrong with the machine and then have them come back and get parts. In many cases, they can fix what's wrong just by dialing in without ever having to send out a service rep. So there's lots of efficiencies to be gained there. So that's sort of our first foray more towards mobile IoT and adding on to telematics. The other area is through connecting those motion systems components. So whether it's hydraulic or pneumatic or electromechanical, we make those pumps, those valves, those filters, sensors, accumulators, motors. That's what Parker does. And we see real value in connecting into those components as well, because those components are critical to whatever the utility is of that machine, whether it's picking stuff up or moving it or stacking it or crunching it. Those parts drive that utility. And then finally, we provide an end-to-end solution that connects all of that, and we can do analysis on the edge and in the cloud and provide a myriad of services to the customer that's going to help them manage that machine in a more effective way. Hopefully that answers your question.
Yeah, definitely.
Okay.
So what are maybe some of the components that are necessary, or software or other technologies that might be necessary to integrate IoT into fluid power systems?
Sure. So the basic components are some form of connectivity. And that is pretty traditionally done through a gateway today. I imagine it's going to be that way for the foreseeable future. But beyond that, then the interface with the controllers, you can do that through the bus that's there today, or Ethernet. There's different technologies for integrating. We have multiple ways of integrating today. And then we have sensors that in some cases we've already integrated onto our core products, our pumps or valves. We also have standalone sensors that can measure many different things on the machine. So it is a myriad of hardware, software, sensors, and then there's services that's all wrapped around it. So it is very much a SaaS offering, if you will.
Mm-hmm. Okay. And so what are the maybe some things that need to be kept in mind when integrating IoT into fluid power applications, or maybe some challenges and ways those challenges could be overcome?
Gotcha. That's a good question. I would say if you look at it on different levels, I would say standard condition monitoring of the motion system is something that can be widely taken advantage of today. It does take some knowledge of, say, a hydraulic system if that's what you're working on, because you'll need to know what are the key indicators on that particular component or subsystem that you're trying to to implement. From there, you got to collect the right sensors, you got to pick the right sensors, deploy them. From there, as long as you have a system, an IoT system that allows you to connect that, then you're well on your way to condition monitoring. So you can pull that information into the cloud. You can know if that pump is operating outside of its guidelines. You can know if there's too much pressure built up across that filter, and you can know if you need to go take action there. That's, like I say, pretty standard stuff that's pretty readily available to anybody in the industry today. Going beyond that, though, if you want to get more into, say, predictive capability, to me, that is going to take a lot more specialization. Because there you got to have deep knowledge of whatever you're trying to instrument, that component, that pump, that valve. You would need to understand the design of it, the operations of it, the failure modes of it. You'd have to have capability to analyze data across all that to be able to train a machine learning algorithm. You'd have to have edge capability as well as cloud capability. You'd have to have some data sciences that can take care of that data and manipulate it and do the analysis that you need to do. So it's a lot more involved if you want to get into predictive. But condition monitoring on top of standard telematics today is something that most people can do, I believe.
Mm. Okay. And are there certain types of components or systems which are maybe best suited for the use of IoT, or can it be something that can be applied across the board?
That's a good question. When I look at off-highway machines, I think that IoT is applicable to most of it. I really do. I think the vast majority of off-highway machines can take advantage of it. Now, there are considerations that you have to take into account. There's technical considerations. How difficult is it? How complex is it to design that solution to track that particular application? For example, we've done things where you have to measure how much of a particular chemical is being applied to a certain square footage of road over a certain period of time. So you are tracking data at sub-second intervals, and multiple elements of data are coming into play. So you can generate a very detailed report that someone is going to take to a municipality and say, see, I did my job, please pay me. Other applications may require that you have to interface with an enterprise application.
Mm-hmm.
Those things can be really tricky depending upon how old they are, their APIs and SDKs available. So there's technical considerations, there's obviously cost considerations. What's the expense of that machine, of the products that are going on, what's the expense of downtime. There's a lot of cost considerations that have to get taken into account, and how costly is it to build that solution, deploy it, and support it in the field. Running a machine 4,000 miles away, it gets pretty tricky. And then the value comes into place as well. And value, I hate to say it, it's relative. It really is, depending on both the application and where you are in the value chain. Because the value is different depending on if you're the OEM or the service rental company, or you're the owner operator, or you're a provider of parts like Parker and subsystems like Parker. And so there's a lot that you have to take into account. We take a more old-fashioned approach. We go talk to our customers and we get in tune with what they're looking for. And they will surprise you with what drives value to them. I guarantee you talk to your customers, you're going to find out things from them that you would have never thought, sitting in a room talking with your people that make pumps or valves, if you get me drift.
Right. Okay. And so, does Parker Hannifin see the integration of IoT continuing to progress in the coming years? And are there
Hmm.
maybe is there anything that needs to still happen to help it become more widespread within the various industries?
That's interesting. I believe it is going to trend up in the future. Uh, Today, you have a lot of machines that are connected off highway, a lot, right? And that's again
Mhm.
because of the long history of telematics. Um, Most of the large tier one OEMs have deployed some form of telematics, and that information is being used to inform their service channels, their dealer channels, and allowing them to engage the customer in a more informed fashion. A lot of that, again, is focused on location and what's going on with the machine itself, the engine, the transmission. Um, Based on the feedback that we're getting, telematics works for most customers today, but it's limited.
Mhm.
Most of these systems, these Gen 1 telematics systems, are designed to capture certain data points, a very limited number of data points, and they're optimized for cost, which means they don't necessarily have the flexibility that you're going to need to enable over-the-air operations or to enable smart product applications. And because of that, we are seeing interest from people that have a basic telematics solution today that are interested more in mobile IoT. They want more capability out of their connectivity is what they're looking for. Beyond that, I think OTA, smart products, faster data transmission speeds, edge analytics, advancements in sensor technology, lower cost sensor technology, all those things, plus the customers wanting to move beyond basic telematics, I think are going to drive more mobile IoT, not just with the Gen 1s or the tier 1 OEMs, but with the tier 2s and the tier 3s. Uh, Lots of discussions in those tiers as well. Lots of activity in those tiers.
Mhm. Okay, great. Well, those are all the questions I had. I don't know if you had anything else you wanted to add or thought our audience should know about kind of technologies or trends regarding IoT and fluid power applications.
Well, you brought up value.
Hmm.
So I would say value is something we talk about with every customer. It always comes up. Um, and the thing that I would say to keep in mind is that it is relative. Value is very relative. I like to say based on the application and based on where you are in the supply chain, as I said earlier. And telematics has a lot of value. A lot of people who are managing fleets take advantage of location information that they get off of telematics, and that allows them to route machines more efficiently or plan for maintenance or know the location, obviously, of those machines.
Mhm.
Um, an OEM would be highly interested in knowing what is the service cycle or the hours of usage or the duty cycle on the hydraulics. They'd be very interested in that so that they can inform their service interactions with their customers. Others would be highly interested in tire information. We have very small shops in some cases that are operating rough terrain machines that have very expensive tires, $5,000 tires or higher.
Right.
Um, and if that's the case, and they could be subject to being punctured in these rough
Mhm.
terrain environments. Now you have an internal tire that's punctured, and the external tire is going to wear out much quicker, or it's going to be subject to a puncture, if you will. So tire monitoring could be of high value to some customers and lower value to others. So all that comes into play. Seatbelt monitoring, monitoring fluids, impacts to the machine. There's lots of different things that customers want to monitor, and the value will vary. Electrification is something that we are connecting more and more machines today that are using electrification to drive the machine itself, but also the hydraulics. And they are looking at a myriad of information on
Mhm.
the battery, on the motor, the state of charge, and the usage, the energy, the range. They're looking at a lot of stuff there. So depending on what your application is and whether you're the OEM or you're the operator or you're the rental agency, it's going to have different value to you. So it's not a one size fits all. So I can't sit here and tell you every machine is going to want this. I can't tell you that for sure.
Mm-hmm.
But I think there is value for most off-highway machines.
Mm-hmm.
And today we connect material handling machines, like let's say reach stackers or forklifts,
Yeah.
construction machines such as cranes, forestry machines such as let's say harvesters, loaders, forwarders. So wide range of equipment is connected today, taking advantage of these solutions.
Mm-hmm.
And in every case, we're going down standard telematics and we're connecting with the motion system to provide a more mobile IoT experience.
Mm-hmm.
So anyway, that's what I'll leave you with, unless you have any other questions for me.
No, I think that's it. Thank you very much for speaking with me today and providing all of the insight that you have.
Okay.